Okay, that is about the first chapter, the basic information, okay, basic background information. Now, let's search chapter 2. Chapter 2 is one industry application for 5G. That is the IoV. IoV means Internet of Vehicle. Chapter 2, we have 4 sections. Section 1, introduction. Section 2, requirement. Section 3, solution. And section 4, use case. So let's first have the introduction. IoV. So what is IoV? So IoV is abbreviations here, Internet of Vehicles. Internet of Vehicles. That means that we want to connect the vehicles with the network for communication. So why do we need the communication for the vehicles? Because we want the vehicle driving more smartly, okay, more efficiently, okay, and even automatically, okay. So to enhance the safety, enhance the efficiency, and even automatic driving. So this Internet of Vehicle is also called V2X. Okay, V2X. V means vehicle. X just means everything. V2X is vehicle to everything. The communication from a vehicle to everything. To what everything? Here. Like vehicle to vehicle. These two vehicles can exchange information with each other. For example, this vehicle can detect some obstacles in the front. Then it can send the information to the vehicles behind it, okay, to have some pre-actions, avoid this accident. Okay, vehicle to vehicle, a vehicle can share information with each other. Okay, and then vehicle to P. P means pedestrian, person walking. Okay, pedestrian. Of course, the pedestrian should also carry some terminals. Okay, can communicate. Okay, for example, you want to call a taxi like this. Okay, and also for some safety communication, there can be. Okay, so vehicle to pedestrian. And the third one, V2N. V2N means a vehicle to network. Vehicle can communicate with the mobile network. It can get plenty of information from the network. For example, the dynamic map, and a vehicle to I. I means infrastructure, like the traffic light. And there can be also guide board. So the vehicle can also communicate with the road. Okay, the road side, we can have a lot of I means infrastructure. Okay. So these are just a V2X. Okay, it can form one big network. Okay, with this V2X, V2P, V2I, V2N, and then also V2V. Okay. So this is the IoV, Internet of Vehicles. And for the IoV, currently there are 2 solutions. One is called DSRC. The other is called CV2X. V2X we have just known. Vehicle to everything. Okay, C means what? C means cellular. Using a cellular system, like a cellular system, the typical cellular system, 4G, 5G, okay, 3G. These are cellular system, right? Okay. So cellular V2X and DSRC. And what does DSRC mean? DSRC means dedicated short-range communication. Dedicated short-range communication. And this DSRC is based on the IEEE 802.11p. Okay, it is something like Wi-Fi, WLAN. Okay, now. This was released very early. It's in 2010, 9 years ago, around 10 years ago. And also in 2013, the ETSI, which is a European organization, also released one standard in Europe. So this is released very early. Now it has already some deployment, deployed in some countries. The spectrum is using, in some countries there are dedicated frequencies, but also in some countries are just using public frequencies. Okay, and the communication latency and the range is, latency is around 50 milliseconds. The vehicle-to-vehicle communication, the delay will be around 50 milliseconds, and the distance is around 225 meters at the speed of 140 kilometers per hour. With such speed, okay, it can communicate in the range of 225 meters. Okay, so this is about the technical parameters of this technique. Another one is V2X. V2X, it's just known that there are a lot of things related vehicle to vehicle, okay? Vehicle to infrastructure, vehicle to person, vehicle to the network, okay? Many paths of the communication. So their information is more sufficient, okay? And it can have higher efficiency and higher reliability, of course, okay? Because information is more sufficient. And this is the standard is from 3GPP, okay, 3GPP based. And for the CV2X, there are C2X for LTE and C2X of 5G. The technical parameters, look at here, okay, 20 milliseconds for the delay with the release 14. Release 14. And with release 16, this latency will be 1 millisecond. This is about the delay of different releases. And the communication range is 450 meters, 450 meters at the same speed, 140 kilometers per second, per hour. So you can see that the communication range is a double of this one. And the latency is also very short comparing with the DSRC. So you can see, comparing with these two technologies, of course, CV2X performance will be much better. And now in China, China is leading in this technique. China is now already doing some tests in the CV2X. Yeah. So why do we need this CV2X? So here we can see one traffic accident, a very famous one, the Tesla accident. The Tesla electric car, okay, driving along the road, and here is a T-cross. A truck is driving from the other direction, and is having a left turn, okay, at the cross, left turn. The truck is in white color, When it turns, okay, the side is facing the Tesla car, okay, and this Tesla car detected this truck by the camera in this Tesla. Okay, the Tesla car is in automatic driving mode, but this automatic driving is local automatic. It is not without the network. Okay, all the detection, all the decision are made locally by the local computer inside this car. Okay. So this car has detected this truck. The camera detected, but it's in white color. It takes this white color as the color of sky. Okay, it cannot recognize it is a truck. It takes it as a sky. Okay, and also the radar in this Tesla car also detected this truck, but it takes it as traffic guide board. Okay, also it's a mistake. So this car has no action. Okay, no braking. It just drives forward. Okay, and it hit the truck, and it passes through the truck under it, and hit two fences and one pole. is a very severe traffic accident. So why this happened? Why this accident happened? It's just because of this local single intelligent is not reliable. It's not reliable. If it makes some mistake, this is critical. Okay. So if prior to this time, if this car can receive the information of this truck, it can have brake, okay, prior to it, and it can avoid this accident. Okay. So if use the cellular V2X, and this will be much better because our C V2X network will send the dynamic map to this car. Okay. So the C V2X we have already known. Okay. Many ways of communication. Okay. And here below is a comparison between CV2X and the DSRC. DSRC. The below color is DSRC. DSRC communication range is 2 to 5 meters, and it can have a reaction time. For example, here you need to step on the brake. This reaction time is 3.3 seconds. And the green color is a situation of CV2X. Its communication range is 450 meters. And the reaction time will be 9.2 seconds. So you can see this one gives the driver more time for reaction. So this, of course, will be more safe in this way, comparing these two. So we need a network for the vehicles, IoV. And we can say that CV2X will be better comparing with DSRC. And about the automated driving, or about the IoV development, we can know this as the development of the automatic driving, like this. Okay, automatic driving has 6 levels, from a level 0 to level 5. Level 0 to level 5. Level 0 means there is no automation, just the manual driving. Okay, and level 1 is driver assistant. It can assist some functions of the vehicle, like lane departure prevention or adaptive cruise. And already realized vehicles. Actually, this can be realized by 2G, 3G, or 4G. Even without the network, these two can be realized. With the network, we can have some in-vehicle information service. Some music, some maps, okay, some view. This information can be provided by the network. It's not related to the traffic. Okay. So this has already been realized. And for level 2 and level 3, partial automation or conditional automation. Partial automation like this lane departure prevention and adaptive cruise at the same time. Or conditional automation like automated driving in a traffic jam. Okay. When there's traffic jam, you need to brake, start, brake, start, brake. Okay. If this manual operation is very tiresome, okay, and we can turn to automatic mode to let the computer to control this automatic driving. Okay. So this is, of course, that case is of very low speed, right? And also in some, for example, in some closed campus, in campus, also is conditional automatic automation. Okay. So condition 3 means level 3 means conditional automation. That's under certain situation, under certain condition, okay, supported the automation. So for the level 2 and level 3, we need the CV2X network, and LTE can satisfy it. Okay, LTE, okay. That's already enough. And for the network side, we can also provide a traffic light guidance. It can be a little bit intelligent. We can guide the cars. For example, here you have let's say here is a green light, and then we hope that when you reach the next traffic light, it will be also green, so that you can pass through quickly. Okay, so we can coordinate the traffic light, okay, according to the traffic flow, okay, intelligently. This some places also is now doing the test. Okay. This is traffic guidance. And for level 4 and level 5, these are automation. These are real automation. For, say, high automation, like this robot taxi. Robot taxi means that the taxi running automatically with no drivers inside. Okay. And level 5 means full automation. That is automation under any situation, any under condition. This is the last level and the highest level. We call it the full automation. Level 4 and level 5, we need a very, very, I'll say that, very strong network. Now, this network should provide enough bandwidth and provide very good reliability and a very short latency. Okay. And in this case, only 5G V2X can support. With LTE, the latency and the bandwidth cannot meet the requirement. You can see that is fully automated. Okay. For 5 and 4, and for 2 and 3, it's just for intelligent and connected service. Okay. We cannot have full or high automation. So this will be the development of the IoV, okay, from no automation to partial automation and conditional automation to high automation and full automation. And the V2X has 3 stages. That is the LTE V2X, and the LTE V2X, and the 5G V2X. LTE V2X is from 3GPP release 14. Okay. And LTE V2X, this is release 15. Release 14 from the year of 2017. Okay. And this one, the year is an enhancement of V2X, LTE V2X. LTE V2X can help to enhance the safety. Okay, we can say that it can provide proactive safety, and it can also improve the traffic efficiency, and also it may provide some information entertainment. Okay. And eV2X is an enhancement of it. Okay. The speed, okay, the bandwidth and the latency is enhanced. Now, the service type is the same. And for 5G V2X, this will be based on release 16, which will be in the next year, the first quarter of 2020. And this can provide us fully automation for the automation. And this 5G V2X can support the 4 scenarios, which are also be very low, right? That is the scenario of low latency, high reliability and low latency. And also the throughput should be broad enough, because we may change some maps. The map may contain very detailed information, and we may also exchange some high resolution video. It's also possible, right? So we also need broad bandwidth. So for broad bandwidth, for high reliability, for low latency, okay, LTE cannot satisfy the requirement. So we need 5G. We need a new technology as 5G to support such features. And with the low latency, with the high reliability, with the broadband throughput, it can provide us the improved experience, enhanced capacity, and intelligent cooperation. And yes, and we will use the 5G V2X automatic driving decision cooperated, like the cooperation with neighboring vehicles, cooperation with the network. The network will have shared information exchange. Okay. So it will be more reliable and more intelligent comparing with the single vehicle intelligence. Like the Tesla, single, there's traffic accident. Okay. And with the cooperation, this situation can be much, much better. So that is why we need 5G for the automated driving. And the 5G can provide us MEC and network slicing. These two features of 5G can provide us advantages. Look at this one. This is the MEC, mobile edge computing. The application, of course, for the automated driving, we need the application, right? Okay. The application can be installed, of course, in some server. The server can be near to the base station. And of course, it can be far away from the base station. If it is near to the base station, then the responding speed will be higher, right? And for the automated driving, of course, we need this responding speed to be fast, low latency, okay? To make the latency lower, then the application is better installed near the latency. You can imagine if you're using the effort and the throughput, it cannot guarantee your latency. Okay. So with the slicing function, the QoS can be guaranteed. And here is some scenarios of the IoV defined CV2X scenarios, like this crossroad collision warning. You are crossing a road cross, and then it can send you the dynamic information if there's some other cars coming from another way, okay, to prevent the collision. Okay. Collision warning upon lane change. You want to change the lane, okay, to avoid collision. Okay. Sudden stop warning ahead, collision warning, congestion notification, roadside construction reminder, okay, danger reminder of a motorcycle or side blocking, and emergency vehicle avoidance, like if there's an ambulance or there is a fire engine, okay, we need to give the way, okay, for the emergency. Information broadcast for RSU. RSU is a roadside unit. The roadside unit may broadcast the information of the dynamic dynamic information of the traffic. Yeah. Dangerous road broadcast, dangerous weather warning, speed limit reminder, and all of these you can see are related to the safety. Okay, related to safety. These are 12 basic IoV scenarios defined by the 3GPP. Okay. And additionally, there are 4 advanced scenarios, high-level scenarios. And these 4 scenarios are related to the automated driving, like this vehicle platooning. Usually this is by the logistics transportation. You have a troop of trucks, and you need a lot of drivers, right? Let's say you have 10, okay, 10 of trucks. Of course, you will need 10 drivers. And with this vehicle platooning, you only need 1 driver. 1 driver in the very beginning truck. And the other 9 following it are in automatic driving, following it. Okay. So this can save the labor cost. And it can also save the energy. The fuel consumption can also be reduced using this way because it can be driving in a constant speed and with a constant interval inside between them. Okay. It can also save energy, save drivers, save energy. Okay. This is one scenario for the automated driving. It's called vehicle platooning. Another is overtaking human beings' work. It is automatic driving. Automated driving. It's also called advanced driving. And the sensor information sharing. The vehicles on the road can share the information from their sensors with each other. Maybe directly, maybe through the network. This is sensor information sharing. And last one, remote driving. Remote driving is that you have a vehicle away from you, okay? And you can drive it here locally. It's just like playing a game. Okay? You can control the vehicle, remote driving. And here are some requirements of the network for these 4 scenarios. Like for the vehicle platooning, it needs 10 to 25 milliseconds for the latency. And it needs the reliability around 99.99%. Okay, it's the reliability. And the throughput, it needs 50 to 65 megabit per second. That is the throughput needed. And the communication range from 80 to 250 for this scenario requirement. And the overtaking, it needs a higher reliability and with very low latency. Latency from 3 milliseconds to 100 milliseconds depends on the speed. If the speed is fast, we need very low latency. And if the speed is slow, latency is not very much, not that much important, right? Okay. So this latency is related to speed. Okay. The higher the speed, the short the latency needed. And for uplink throughput and downlink throughput, and the communication range. And other sensor information, the remote driving also have these parameters. And all of them, they need a relatively short latency, okay, and high throughput, okay. And with this one, 5G will enable this efficiency and higher safety using 5G for these 4 scenarios.